for the timer. Hi, Chris, or any other student in the future who's watching this lesson over piecewise functions. You guys want to say hi? So, all of you are named Chris who are listening to this lesson. So, we are talking about piecewise functions, which means that there's going to be at least two different rules. So, underline or write that down. It'll look like this, right? Y equals, and it might be the absolute value of x minus 2 for x that's less than 0. And maybe it's just 5 for x that are greater than or equal to 0. So that's what a piecewise function is, if you guys remember. It's different rules right there over different subsets of the domain. You guys have done this before? I think so. So the two goals that I want you to know how to do is, number one, evaluate function values, and number two, graph them. So I thought we'd do a couple examples. Now, one thing that confuses people sometimes is that they see two rules, and when I ask them for f of something, -2, f of -1, f of 0, we'll do 4 of them. Sometimes they think that you have to plug it into both rules and you'll get two different answers. Okay? But in a function, when you put one x in, how many y's do you get back? 1, that's right. So that means we have to make sure that we realize that each one fits into a different subset. So if I get rid of these again, and let's just go with the top portion, says I use this rule when x is what? Less than 0. So how many of these values are less than 0? 2 of them, right? So for this one and for this one, right, I'm going to do x minus 2 with the absolute value. So -2 minus 2 would be -4. And that would be 4. Or -1 minus 2. That'd be -3. The absolute value is 3. But these values, 0 and 1, are greater than or equal to 0. So I would use the value of just what? 5. So that's evaluating. And when I come over here, what I have to realize is that whatever this line here, this number right here, this number divides the graph. So where is x equal to 0? That's right in here. So when x is greater than or equal to 0, 1, 2, 3, 4, 5, the y value is going to be 5. And when it's less than 0, it's going to be the absolute value of x minus 2. And the points we plugged in at -1, it was 3. And at -2, it was 4. And you might ask, well, what about as I go this way, right? As it gets closer to 0, what would it be at 0 if I plug 0 into this? Take the absolute value of that, it would become +2. So I'm going to put an open circle because that's what it would be at the very end of that piece of the function. So that's my piecewise graph, and then those are my evaluated values.